Welcome to qnawire.
Welcome to the problem number 22.46. This is chapter 22, Go Slow. So this is what we have here. So we have two concentric spherical shells. Concentric spherical shell has inner radius A and outer radius B, and the outer spherical shell has inner radius C and the outer radius D. So this one contains plus 2q charge and this one contains minus 2q charge. So these are conducting materials. So these are conducting materials. So whatever the charge is on the inner conducting shell or the spherical shell moves towards the surface. So this 2q is on this surface. So the whole charge 2q is on this surface. There is no charge on this one. Now, so this 2q will induce minus 2q on this one, and then it will induce plus 2q on the outer one. And there is already minus 2q here, so this will become total charge 0 outside. So let me make the another diagram. So after induction means the charge induced charges on the conducting material. So we have the inner one, radius A. We have the outer one. So this has radius A, this has radius B. The charge is on q 2q. There is no charge on this one, so this contains 2q. Now going to the outer spherical shell. So this has radius C and this has radius D. I have drawn some bigger to make it more clear. So this is radius C and this radius is D. So after induction, so we have minus 2q on this one and 0 on this one. So 2 minus 2q is on this surface and that 2q is on this surface. So this surface don't have any charge and this surface don't have any charge. So let us find out the electric field between all regions. So we have a part of this question. So first we need to find the electric field at r less than a. Since this contains no charge, the electric field is 0 using Gaussian law. Second, we have a less than r, which is greater less than b. So again, there is no charge inside that. The charge is on the surface having radius b, and we are talking about this region. So again, there is no charge. So we have e equals to 0 again. Now we're talking about third part, which is b less than r, which is less than c. So we're talking about this point between them. So the inside charge is 2q, and this is a sphere, so we can consider it as a point. So electric field would be 1 over 4 pi epsilon naught 2q over r square. So that's your for our third part of a part. Now going towards the d part or the fourth part for a part. So we have c between c less than r and r less than d. So we're talking about this one here. So we have 2q charge on this one, and again, so we have minus 2q in charge on this one. So that would mean there is no charge contained. If there is no charge contained, so that means that q total is equals to 2q minus 2q, which is equals to 0. So using the Gauss law, we have again electric field 0. Now talking about the fifth part, which is r greater than d. So we are outside that. So this is the same situation because there is no charge again. So q is 0 again. So E is equals to 0 here again. So this is your electric field for all the regions. Now let's go to the part B. Oh yeah, we have one more part. So we need to plot the electric field versus R. So electric field is this one, and this is our R. So talking about this one here, so we don't have any electric field till R equals to B. So at R equals to B, we have electric field going inversely proportional to R square. So we have, and this is till R equals to C. So, and there is no electric field greater than C, and there is no electric field less than R equals to B. So that's your graph for E versus R. Because we have 1 over R square, that's why we have this graph. Now coming back to the part B. So the surfaces, I have already mentioned what are the charges of the each surfaces. So we have inner spherical shell, inner surface, charge is 0. Outer surface of this one, charge is equals to 2q, which is this one, 2q. We have outer spherical shell and the inner surface of this one contains q equals to minus 2q, and the outer one contains 0 charge. So we have outer one, outer surface equals to 0. So that's your answer for your part B, and we are done with this question. Yeah, so we're done with this question. So that's your answer for this question. Thank you for watching the video.